So let's rewind a bit to late 2023. The AI world was absolutely buzzing with these super powerful individual agents. But they all had this one secret weakness. They really struggled with complex, multi-step problems. The real breakthrough, it turns out, wasn't about making a single AI smarter, but about teaching them how to work together. This is the story of AutoGen, the Microsoft research paper that basically introduced the art of AI teamwork.
All right, so here's our game plan. First up, we'll explore the multi-agent revolution and the big problems AutoGen was designed to solve. Then, we'll get into the nuts and bolts of how these agents actually talk to each other. After that, we'll look at the proof. Did this new approach actually work? And finally, we'll talk about AutoGen's legacy and take a fun, speculative look at where this whole thing could be going. You see, before AutoGen, the main idea was just to build one massive AI, a kind of jack-of-all-trades agent. But when you give it a really complex task, say planning a whole vacation itinerary that also needs to book flights and check weather APIs, these single agents would just hit a wall. They'd get stuck in a loop or just fail completely, unable to fix their own mistakes. The number of variables was just too much for one AI to juggle. And this really gets to the heart of the problem, right? Getting different AIs to cooperate was the dream. But the early attempts were, well, they were clunky. You might have a coder agent and a tester agent, but they couldn't just have a normal back and forth. The communication was so rigid and pre-programmed that if anything unexpected happened, the whole system would just fall apart. This timeline really shows you just how fast everything was moving. In early 2023, you had these lone wolf systems like AutoGPT. They were really impressive, but they got stuck a lot. Then boom, August comes around, the AutoGen paper drops, and it completely reframes the problem. It wasn't about building a better lone wolf, it was about building a coordinated pack. And that architectural shift really paved the way for the more sophisticated multi-agent frameworks we're seeing today. Okay, so this is the big idea behind AutoGen, and it's just so elegant and powerful. Instead of trying to create some super complex, rigid plan for an AI to follow, the researchers realized you could just model any workflow as a conversation. You just create a team of specialists and give them a structured way to talk to each other to solve a problem. Simple as that. So the first piece to the puzzle is what the paper calls a conversational agent. And this is a really flexible concept. An agent could be a powerful LLM, sure, but it could also be a human operator giving feedback, or even just a simple tool that runs code. The genius part is that they all talk in the exact same way, by sending and receiving messages. It makes the whole system incredibly modular, like they're Lego bricks for AI. And if the agents are the Lego bricks, the second key idea, conversation programming, is kind of like the instruction manual. It's the rules of engagement for the team. As a developer, you don't have to micromanage everything. Instead, you just define who's on the team and set some general guidelines for how they should interact. For example, the coder speaks first, then the critic agent reviews the code. It's this perfect mix of high-level direction and agent autonomy.
So let's make this real. The default team setup has two main players. On one side, you've got the specialist. Think of this as your brilliant, heads-down coder. It's an LLM that writes code and comes up with solutions. But on the other side, you have the project manager. And this agent is absolutely crucial. It's like a proxy for the user. It's the one that actually executes the code, checks for errors, and can even pull a human in for feedback if it gets stuck. This division of labor is what makes it all work.
And you might think setting this all up is super complicated, but check this out. This conversation programming is surprisingly simple in practice. A developer doesn't need to write hundreds of lines of complex logic. Nope, you just define the agents on your team and give them their first task. The AutoGen framework handles all the complicated conversational stuff from there. And that little bit of code, it kicks off this amazing autonomous conversation. Just imagine, the specialist agent suggests a piece of Python code. The project manager agent takes it, tries to run it, and immediately gets an error. Maybe a required library isn't installed. Instead of just failing, it reports that error right back to the specialist. The specialist then says, oh, okay, here's the command to install the library. This self-correcting feedback loop is what makes the whole system so incredibly robust. Okay, so the theory is super impressive, right? But talk is cheap. How did this AI team actually perform when the rubber met the road? Let's dig into the numbers. First up, a massive win for developers. They took a complex supply chain tool called AutoGen, and by implementing it with AutoGen, they slashed the code from over 400 lines down to just 100. That is a 4x improvement in productivity. It's huge.
And for the actual person using the system, it became way more autonomous. We're talking 3 to 5 times fewer manual prompts and corrections needed from the human. Why? Because the agents were handling all that tedious back and forth themselves.
Now look at this. On the notoriously difficult math benchmark, the standard 2-agent AutoGen setup performed incredibly well. It even beat out heavy hitters like ChatGPT with Code Interpreter. This really suggests that having one agent propose a solution and another one execute and verify it, well, it's just a smarter strategy for complex reasoning than having a single agent try to do everything.
And this result here is a fantastic example of AutoGen's modularity. The researchers started with a standard 2-agent system, and it did pretty well. But then they added a third, highly specialized grounding agent. Its only job was to provide common sense feedback. And just by adding that one new team member, boom, the overall success rate jumped by 15%. It just goes to show how easily you can enhance the team's brainpower by adding new specialists.
So AutoGen didn't just give us a new framework. It really established a whole new way of thinking that has deeply influenced the entire agent ecosystem. But, like any great piece of research, it also shined a light on the challenges that are still ahead of us.
If you look at the paper's own comparison table, you can see what made AutoGen so unique at the time. Unlike other systems with these rigid static communication patterns, AutoGen's was flexible. And crucially, it was built from the ground up to actually execute code and to keep a human in the loop. Those were game changers.
One of the things I really respect about this paper is how upfront the authors were about the new problems this approach creates. They raised these critical questions, like how do you even design the optimal team for a specific task? And as these agent teams get bigger and bigger, how do we make sure they're safe and accountable? AutoGen didn't solve these problems, but it gave the entire field a new framework for trying to tackle them.
So, the paper lays out this incredibly powerful framework for AI teams. For this last part, let's have a little fun. Let's take these ideas and push them to their logical extreme and see where we end up.
AutoGen gives us the blueprint for small, effective teams of 2 or 3 agents. But what happens if you don't stop there? What if you scale it up to dozens or even hundreds of agents? It leads to this pretty wild question. Could you use these same principles to create entire autonomous organizations? It might sound like science fiction, but honestly, the building blocks are all right there in the AutoGen framework. You could define agents with roles like a CEO, an engineer, and a critic. You could use a feature called the Group Chat Manager to act like a boardroom, deciding which agent gets to speak next. The team could collaborate on a task, and the CEO agent could even be programmed to monitor progress and hire new specialist agents when needed. And this isn't just us going off on some wild tangent, it's a logical extension of the paper's central argument, which is summed up perfectly in this quote. The key insight is that dividing tasks among modular, specialized agents is the best way to handle complexity. The paper applied this to building software, but there's really no reason the same principle couldn't be applied to building an entire organization.
This is for entertainment purposes only.